Okay, how you guys doing there? Hopefully doing well. Anxious to come back to school, hopefully. I know I am. Have you guys back here. So anyhow, we're done with section 3-1. We're going to start section 3-2 today. I think you're going to find section 3-2 is super easy. You're really going to like section 3-2, I think, if you watch this video. So anyhow, just so you guys know, and I'll say this at the end of the video, this assignment is due on Friday the 13th, Friday the 13th. Friday, November 13th. So anyhow, I think if you get right on it, this section is going to be, it's not real long and it's pretty straightforward, okay? So we're just gonna dive into this section 3-2. It talks about linear equations, linear functions, okay? So we're gonna just dive in on number 5 on section 3-2, okay? So when we look at number 5, they give you graphs. The first few problems, they give you some graphs. And this one looks sort of like this. And they ask, is that a linear function? Okay, well, is it a linear function? No, there's a real simple reason. It's not a line, okay? It's a non-linear function because it is not a line. So filling in the blanks, it's a non-linear function because it's not a line, okay? Is not, oops, but is not. So those are the blanks you're gonna have to fill in. Actually, I think it's just click and drag them down. So that's all you gotta do for that. It's that simple. They get a little harder here, okay? Not much, but I mean, if you look at number 7, they have a graph that looks sort of like this. They ask us if this is a linear function. Well, you look at it, it's a line. So that is a linear function, okay? So it represents a linear function because it is a line, okay? Simple enough. We look at question number 9, same type question. They're not all like this, but there's a lot of them that are like this, okay? This is straightforward. They give us a graph that looks like this. They say, is that a linear function? No, that is non-linear because it is not a line. Now, if you're going, well, it's 2 lines, it doesn't matter. It's got to be one straight line, okay? So that's non-linear because it is not a line, okay? It is not a line. Okay, now this is where they get a little bit harder, but not much. I mean, those ones I'm thinking are pretty easy, okay? Now they're not going to give you a graph, okay? If you want to draw a graph and see if it all falls on a line, you can do that. That's not the way I'm going to show you, though. Okay? They give you a table of values. We have the x values of 1, 2, 3, and 4, and the y values are 5, 10, 15, and 20. Now they ask us, is this a linear function? Okay? Now, and this one's got several reasons why it is or is not linear. So first off, we got to find out, is it linear? Okay? So what has to happen is this. I'm going to say this a little slower here, okay? The x values have to have the same thing happening, and the y values have to have the same thing happening, but they don't have to be the same thing. What I mean is this. What's happening to x? 1, 2, 3, 4. It goes up by 1. Up 1, up 1, up 1, every time. Now, are we also going up 1 on the y values? No. We're going up 5, up 5, up 5. So are we doing the same thing to the x values as we are to the y values? No, but the x's, we're doing the same thing to every time. Adding 1, adding 1, adding 1. Y's, we're adding 5, adding 5, adding 5. That is linear, okay? That is linear. It is a linear function. So if you were to graph that, they would all fall in a straight line. Okay, and then they have some statements that you want to click on. There's more than one right answer here, okay? The first choice, it says the rate of change is constant. Yes, okay? If something's linear, the rate of change is constant, okay? So that's one you're going to click on. The next choice says the y values are multiples of 5. The y values are multiples of 5, okay, but that's not the reason, okay, that's not the reason, okay, it's not because it has to be adding the same amount every time, okay, so don't click on that one. Third one says the rate of change is not a constant. Well, don't click on that. We've already said the rate of change is a constant, okay. Then the next one says the y values increase by different amounts. No, we already said they're going up by the same amounts. So don't click on that one, okay. And then the next one says the y values increase by the same amount. Yeah. The y values increase by the same amount. Now, they don't have to increase. They could decrease. But either way, it's going to be changing by the same amount. It's either going to increase the same amount every time, or it's going to decrease by the same amount every time. And then as the x values increase by 1, the y values increase by 5. That's exactly what we said before we started this, okay? X increases by 1, y increases by 5. So there's actually 4 of them you want to click on, okay? Well, actually, it's linear, and then there was 3 of them after that, okay? So it is linear, and 3 reasons. You need to make sure you click on every one of them, or you're not going to get full credit, okay? Let's look at number 13. Number 13, let's move this down here. Okay. All right, number 13. And again, they give us data. We have 4, 8, 12, 16. X and Y. 4, 8, 12, 16. So that's good. It's going up by 4 each time. So that's good so far. Then 16, 12, 7, 1. 16, 12, 7, 1. So from 16 to 12, it went down 4. From 12 to 7, it went down 5, which is close to 4, but not good enough. It's not changing by the same amount. So this is non-linear. Okay? This is not a linear function. Now, we need to come up with answers that justify it. The rate of change is constant. No, it's not. Okay? The x values are multiples of 4. That wouldn't be one anyhow. I mean, they're not multiples of 4. But even then, that wouldn't be one that we would pick. The rate of change is not constant. Yes. The rate is not constant. Okay? So make sure you click and drag on that one. The y values increased by different amounts. Okay? They didn't increase. They decreased. But either way, they did change by different amounts. Okay? The y's values changed. How it says increased. Well, it actually decreased. Okay? But they were changing either way. The y values increased by the same amount? No, they didn't. They changed. The x values increased by 4. The y values decreased by 4. No, that's not what happened. It went down 4, then it went down 5. So these are the two that you're going to want to click on after you click on that it's nonlinear. 15. There's 15 at. Okay. Oh, nope, it's not 15. 14 is the next problem. That's one for you guys to do. Let's look at number 17. Number 17. Okay, the next actual problem on the assignment is 17. Okay. Now, they want to know whether this is a linear or a nonlinear function, okay? It says y equals x squared plus 13, okay? That is not linear, okay? And what makes it not be linear is it can't be raised to the power of 2. You can't have exponents, okay? Or the exponents are there, but they're 1s, okay? Y's exponent is a 1, this exponent is a 2. You can't have things raised to the power of 2 to be a linear function, okay? So this is a non-linear function. And because, and it says it cannot be written in this form. And I have to tell you what that form is. This is a form you're going to want to memorize. Y equals mx plus b. We'll talk about that more in the next section, okay? It has to be y equals some number x plus something, okay? So if it was just y equals x plus 13, that would have been good. But x squared plus 13 is no good, okay? All right, so we look at number 19. Number 19. So we have, let's get rid of this. Okay, what's number 19 say? Okay, y equals, this one's interesting. Cube root of x minus 8. Y equals a cube root of 8 minus x. Okay, this one looks a little funky, okay? But we want to find out. Just because it looks weird that doesn't necessarily mean it's not a linear function. This right here is called, it's a cube root of 8. We haven't talked about that yet this year. The cube root of a number means what number do you times by itself 3 times to get that number? In this case, the number would be 2. If I take 2 times itself 3 times, 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. This is the number 2. So 2 take away x. Now, can I rewrite that as y equals mx plus b? Well, y equals, I need to have the x term first, but make sure x is negative, negative x plus 2. If I really wanted to, I could put a negative 1 in front of that. So yes, that is linear. It was a little weird looking at first, but it actually was linear because it can be written in the form y equals mx plus b. Okay? Let's see, skip 20 on to 21. Okay? So we have on number 21, y equals what? 2 plus 1/6 y. Does it say y equals? I don't think it says y equals. 2 plus 1/6 y. 2 plus 1/6 y equals 3x plus 4. Okay, so can we rewrite that as y equals mx plus b? Can we have y all by itself? Well, let's find out. Let's try to write y all by itself. First off, I don't like fractions. Something I taught you once, I think previously, is we can clear our denominators. Multiply everything by 6. That's our denominator. 6 times 2 is 12, plus 6 times 1 is 6. 6 over 6 is 1y equals 6 times 3 is 18x plus 6 times 4 is 24. What's nice about that? No more fractions. Fractions are gone. Now we want to get y by itself because we want to have y equals mx plus b. To get y by itself, we subtract 12. If we do that, we have y equals 18x. 24 minus 12 is 12. So, is that linear? Yeah, we could write it in y equals mx plus b form. Linear because you can write it as mx plus b form. Y equals mx plus b. Okay, that was 21. 23. Okay, let's get rid of this. 23. Okay, 23. So we have 18x minus 2y is 26. 18x minus 2y. Okay, so can we put that in y equals mx plus b form? Yeah, let's see. Let's get y by itself, so we subtract the 18x first. If we do that, these cancel, we're left with negative 2y. Watch your negative. We can't put those together. We want to have our x term first, though. So negative 18x plus 26. That looks terrible. And then we divide by negative 2. Divide negative 2, divide negative 2. If we do that, these cancel. Y equals a negative over negative is a positive. 18 over 2 is 9x. 26 over negative 2 is negative 13. Y equals mx plus b. It's linear because you can write it as y equals mx plus b form. Okay, that's 23. Okay, 27, almost done. 3 more to go. 27. Okay, so let's write this one up on the board here. Okay, so 27. That's just for the domain. This is where it gets a little trickier, okay? So we have like 3 dots. Okay, we have dots at the point 2, 6. And at the point 4, 12. Okay, and what else? Then we have one at 618. 618. 6. I'm going to fudge this a little bit. I'm just going to put 18 up here. Okay, so it's supposed to be linear, but I ran off the board. Okay, so. All right, so it might be easier if I actually list these off. We have the point 2, 6, and then we have the point 4, 12, and the point 6, 18. The domain, okay, the domain are simply the x values, okay? I think we talked about that in the last section, okay? The domain are the x values. Is that what they're asking? Domain and range is the domain. The domain. So the domain is simply the numbers 2, 4, and 6. And that's it. 2, 4, and 6. If they asked you for the range, it would have been 6, 12, and 18. But they didn't ask us that, okay? Now, they want to know if this is the domain is discrete or continuous, and then explain it, okay? Well, discrete means it's just points, like numbers, like 2, 4, and 6, okay? Now, it would have been continuous if I would have connected these dots. That looks terrible, okay? Then it would have been everything between 2 and 6. That would have been a continuous. That would have been a continuous domain. But since they weren't connected, it is a discrete domain. Okay? Because they're individual points. Okay? That's what they're asking. It's because it's individual points. Discrete because they're individual points. If you connect them, then it's continuous. Remember, continuous, you can make the whole graph without taking your marker off the paper. I couldn't make this graph without taking my marker off the board. I put a dot, I put a dot, I put a dot. I had to take my marker off the board each time. Okay, 29. Okay, this one's a little bit trickier. Now they're actually going to give you a couple story problems. And they want, not story problems, but real life situations. And they want to know, is it a discrete or a continuous situation? So on 29, last 2 questions here, 29. They give us the data, x and y. And they tell us what x and y stand for. What do they stand for? X is input bags and output marbles, okay? Bags and marbles. Okay, and then the thing they give us there is 2, 4, and 6. 2, 4, and 6. Okay, and then 20, 40, 60. So apparently what we have here is if you have 2 bags of marbles, you're going to have 20 marbles altogether. If you have 4 bags of marbles, you're going to have 40 marbles all together. 6 bags of marbles again, 60. So it looks like there's 10 bags, 10 marbles in every bag, okay? 10 marbles in every single bag. They want to know, is a domain discrete or continuous, okay? So we had 2, then 4, then 6, okay? Think about it. We're talking about bags, okay? Bags. Well, would that be continuous? Like 2, I mean, the next number of bags would have to be 3, and then 4, and then 5. You can't have like fractions, okay? You can't have like 3.5 bags. I know you can have a bag that's half full, but generally you have 1 bag, and then 2 bags, and then 3 bags, and then 4 bags, okay? That would be discrete because it jumps from 1 to 2, 2 to 3, 3 to 4. You don't have 1.1 bags, okay? So that would be discrete because they're made up of whole numbers, okay? The number of bags must be a whole number, okay? Discrete because they're whole numbers. Last one, 31. Okay, so again, they want to know if this is discrete or continuous, okay? So we have x and y again, and they give us, what do we have here, 369, and what? 150, 300, 450, 150, 300, and 450. And what they represent is x is time and y is distance, okay? All right, now, they want to know this time, is the domain discrete or continuous? Well, we're talking about time here. So we have like 3, I think this is measured in hours, 3 hours, 6 hours, and 9 hours. Well, can there be fractions there? Can you have fractional hours? Can you have like 3.5 hours? Sure you can. Time is continuous. It doesn't jump. It doesn't jump from 1 second to 2 seconds to 3 seconds. There's even tenths of seconds in between there, okay? Time is continuous. So in this case, since we're talking about time, time would be a continuous domain, okay? Continuous, and the reason is because, what do they give us here? Yeah, they can have, well, it says the choice they want to give us because time can be any value bigger than 0, okay? It can be anything. It can be fractions. It doesn't have to be whole numbers, okay? Time can be anything bigger than 0, okay? So, I mean, examples of continuous domains would be like time, temperature. Temperature would be continuous. Trying to think of other ones that would be good. Those are the 2 main ones, okay? But anyhow, like height, measuring height, that would be one also. Weight, height and weight, because those can have fractions. So if you have questions on discrete and continuous functions, that's probably the hardest part students will struggle with in this section. I think just make sure you email me, okay? So anyhow, hopefully you guys got this. This assignment's due on Friday, November 13th, like I said. Like I say, when you have any questions, just email me and I'll try to help you out, okay? Hope to see you guys soon.